It did not record this part. I clicked on it, but I didn't watch it turning. So sorry about that. Okay, I want to look at a word problem that is related rates. Ready? Yes, 97. 97 on page 267. So for some reason, I was not able to record from here this page and this page. Sorry about that, but I will have the notes for you. So this is not new, so I'm really sorry. Okay, 97 on page 267. The volume of a cube is increasing at a rate of 10 cubic centimeters per minute. How fast is the surface area increasing when the length of an edge is 30? I'm going to call it x. So here's a cube. That's my drawing. Here's a cube. Here's x and x and x everywhere. So I am asked to find, I am given that the volume is increasing at 10 cubic centimeters per minute. What is this? I have to identify what is given to me, and then I have to identify what I'm asked to find, and then connect them somehow with an equation. So, what is this? What do I have to write in front of it? dV over dt. Perfect. If that's what you meant, I agree. Good. So now what am I asked to find? Let's read the problem one more time. The volume of a cube is increasing at a rate of 10 cubic centimeters per minute. How fast is the surface area increasing when the length of an edge is 30? I'm asked to find what?
Surface area, which is
No, first the question. What do I have to write here? Very good. Excellent. This is what I'm asked to find. I'm given dV over dt, and I am told find the rate of change of area with respect to time when blah, blah, blah. And if you remember, this cannot come into play till the very last step. Good. So I need two formulas. One formula for the yes, the volume, and the other formula for
surface.
yes, or the area. Good. Total area, total surface area. Good. So what is the formula for the volume of a cube? Very good. What is the formula for the area of a cube?
6x squared.
Very good. We have 6 faces, right? And the area of one is x squared, so this is 6x squared. Perfect. Good. So now I know to differentiate both sides. V and x, are they functions? Are they variables? Is one a function and the other one a variable? What are they? Both functions of time. They are both increasing with respect to time. Good. Or functions of time. Good. So then when we differentiate both sides here, you will get dV over dt, and the right-hand side will be 3x squared. Thank you. Perfect. Very good. So now I do have this. This is given to us. This I don't care for right now, but I do not have this. This is not given to us. Perfect. Let's come back to our area. Leave it alone for a moment. Let's come back to our area. When I differentiate the left-hand side, what do I get? Excellent. Now please tell me what I get when I differentiate the right-hand side. Excellent. So this is what I'm after. This is my question. This will be given to us, no problem. But I have to find this. I have to solve it and put it in. So I have to solve this equation for dx over dt and then plug it in here because everything else is known in order to find this. So can anyone tell us what to do here to both sides in order to get dx over dt? So dx over dt equals, what should I do here? So it's dv over dt all divided by, excellent. I'm going to put it in. Don't put values or anything like that just yet. There is no need for something like that at this point in time. I'm not saying that it could not be easier, but I'm saying don't mess with numbers till the very end. That's my opinion. I accept other methods, as you know. So I have 12x times this, dv over dt over 3x squared. Look what happens. 1x goes away. 3 goes away. So then dA over dt is 4 dv over dt divided by x. So now, only now, I say, okay, so I'm really asked to find how fast is the area, the total surface area, changing when x is 30. So all I have to do is write 4 times 10 over 30. Simplify is 4/3. Without a measurement unit, I can't give full credit. So what is the measurement unit of 4/3?
Centimeters squared.
Per, excellent. Centimeters squared per minute, excellent. Very good, well done. Okay. Let's choose another. Any particular type of problem that you would like to go back to before we choose another? I also want to look at linear approximations. And I'd like to choose a problem from that too. Any particular type of problem, differentiating, logarithmic differentiation, implicit differentiation, any of those? Any of those? Do I pick? Okay, so let's look at the following. Let's find tangent of 44 degrees. Using differentials. Use differentials to approximate. Tangent 44 degrees. Did we do tangent 44 degrees last time? Okay, perfect. You want to change to something else? We can if since we did one trigonometric function, let's say the cube root of 999. Forget about tangent 44. We did a problem with sine. That's fine. Same thing. So now I want to approximate 1 over the cube root of 999. What is the formula? We just wrote it half an hour ago on this formula sheet, on the review sheet. Which formula for approximating? F of plus a little bit of x is approximately. This we have to know. is approximately f of x plus, yes, a little bit of y, which is dy. F prime of x dx. Good. So I have a lot to identify. I have to identify f. I have to identify dx. I have to identify x. So I need f of x, I need x, and I need dx. And of course, after that, I'm going to find f prime of x. Can anyone identify the function for us? Which function are we looking at? Okay, which function are we looking at? I see a function, right? Which function? Very good. 1 over the cube root of x. Perfect. Can anyone give us x? How much? No. X is not 999. Very good. Excellent. Good. How much is x? Dx? Perfect. Now I want to find f prime. So remember, this is x to negative 1/3. So this is going to be negative 1/3 times x to negative 1/3 minus 1, which is negative 4/3. Or negative 1 over 3x to 4/3. But x to 4/3 can be further simplified as 3x the cube root of x. Because I can only take the cube root of 1,000. I don't know how to get the cube root of 999. It's the closest, the first closest cube root. Perfect cube, I should say. Good. So the deviation from 1,000 is negative 1. So that's why dx is negative 1. Okay, perfect. So now let's write this. The left-hand side is what I have. This is it. This part is 1 over the cube root of 999. And then this will be, with calculus, approximated by what? I should also determine f of 1,000. How much is f of 1,000? How much is the cube root of 1,000? 10. So this is 1 over 10. Good. So now please dictate. So 1 over the cube root of 999 can be approximated. It has to be a line, right? I'm using a line, and then I'll get a number. So this is the line. And I will be getting a number. So how much is f of x? We just wrote it here. 1 over 10 plus, I have f prime of 10. So I have negative, I have 1, I have 3 times 10, and not 10, 1,000. 1,000, and the cube root of 1,000 is 10. So negative 1 over 3,000 times the cube root of 1,000 times dx. How much is dx? Negative 1. So this will be 1 over 10 plus 1 over, this is a 10, multiplied by 3,000 is 30,000. And the least common denominator, of course, is 30,000. So this will be 3,000 plus 1. Very powerful result. So now let's check our work with the graphing calculator. So here it is. I didn't mean that. I meant this. So we want to take 999 to power negative 1/3, or we want to determine 3,001 divided by 30,000. Okay? Is this a good approximation or what? Good, so please practice this. Yes, Tony?
So I used the formula the textbook had, and I got the exact same answer.
Right.
Is that okay to use that one?
Can you please tell me which one?
F of a plus f prime of a x minus a.
If you're asked to use a linearization,
Okay.
but I will be asking you to use differentials.
Okay.
You can check with that. This was about differentials. Which page are you looking at?
251.
251 is what I thought. So 251. Okay. Find the linearization. Which are you looking at? Example 1?
2, I think.
Example 2. Let's take a look. Example 2. For what values of? I don't think so.
Oh no, sorry, I'm not looking at examples. I'm looking at the right box too.
Which?
Like there's on page 251 at the very top.
Right, but this is the linear approximation and the linearization. It doesn't say use differentials. The differentials are on the next page, starting from page 253. So differentials on page 253, right here at the top.
Yeah.
So somewhere they have to give that formula. It's not very clear in here. Okay, here it is, right here. F of a plus a little bit is approximately f of a plus a little bit of y. So that's the formula you need. At the top of page 254.
Got it. Okay.
F of x, I used x instead of a. F of x plus a little bit is approximately f of x plus a little bit of y, which is f prime of x dx. dy, by definition, is f prime of x dx. So be careful on that. If the problem says use a linearization, I'm fine. But if the problem is asking for full credit, you have to use differentials. Is that okay?
Maybe I probably did it wrong, but when I was doing the homework, I don't think many of them asked for it that way, so all the practice I had done. So
That's
far,
fine.
like
If
that.
if it doesn't say how to do it, that's fine. Anyway, either way will give you the same thing. Very good. Good question. Thank you. Okay. Let's take a look at find the equation of the tangent line to the graph of, so problem 60. X squared plus 4xy plus y squared equals 13 and 2 comma 1. So find the equations of the tangent line and the normal line to the curve at the given point. So we are given a curve, and we are asked to find the equation of the tangent line to the curve at point 2 comma 1. You know me, I want to check everything. So when I plug in 2 here, I get 4 plus 4 times 2 is 8, and plus y squared, which is 1. 12 plus 1 is 13. Yeah, 2 comma 1 is a point on this graph. Good. So now we are asked to find the equation of the tangent line. What do I have to find? Yes. So I do have y minus y1 equals the slope times x minus x1, and this is 2 and this is 1, but I don't have the slope. Perfect. How do I find the slope? That's my target, my immediate target, correct. How do I find the slope?
What is
Right. So I differentiate the left-hand side and I differentiate the right-hand side. So this is 2x because x is not a variable here, it's just not a function here, but just a variable. But here I have to use the product rule. So plus, leave the 4 outside. I recommend that. Don't mess with the constant. It's a constant. It's a factor. So x prime is 1, y, x, dy over dx, and plus 2y, dy over dx equals 0. Is this step clear? Yes? Okay. Now I will have to distribute 4. You can say, okay, why didn't you distribute it from the beginning? If it's up to you. It's up to you if you want to keep it in or not. So I have 2x plus 4y plus 4x dy over dx plus 2y dy over dx equals 0. So I will have no problem factoring out the dy over dx. And I have 4x plus 2y. But I have to move these two to the other side so they become negative. So finally dy over dx will be negative. I factor out the 2 from the top and the 2 from the bottom. So I have x plus 2y and 2x plus y. So I found an expression that represents dy over dx. All I have to do now is evaluate it when x is 2 and y is 1. So therefore, 2 plus 2 will be 4. And then 2 times 2 is 4. 4 plus 1 is 5. So that is the slope of the tangent line. So all I have to do now is just plug it back in here. Now the question is, what will be the slope of the normal line? So this is M1, and what will be the slope of the normal? Yes, it will be? Very good. I agree. Good. 5/4. And I will just plug it in. Everything will be the same. I will just plug in 5/4 to find the equation of the normal line. Is this okay? Any questions on this? Okay. What if I'm given a function like 81 on 266? h of x equals f of g of sine 4x. We're asked to find h prime in terms of f prime and g prime. So let's think about it for 1 minute. So we're asked to find h prime. Yes, Tony?
F prime times g sine
Of g of sine 4x.
times
Yes,
g prime
exactly.
of sine of 4x times cosine of 4x plus 4.
Excellent. That's it. You don't have to do anything. What I would do, I would put a 4 in front, but it's good enough. That's all I needed. Problem 83. Any questions on 81? Any questions on 81? Any questions on 81? At what point on the curve y equals natural log x plus 4 squared is the tangent horizontal? At what point on the graph of this function is the tangent horizontal? If the tangent is horizontal, what type of point is that? Max or min, correct. But we'll see that in chapter 4. Okay, so now what I wanted is to find the points at which or point, at a point or point, at what point on the curve is the tangent horizontal? What do I have to do? Find the derivative, very good. So y prime will be, yes, times 1 over x plus 4 times the inner function prime, but it happens to be 1. Good. What next? So when the tangent is horizontal, what is the slope of a horizontal line? 0. So I have to set y prime equal to 0. So then I have to natural log of x plus 4, everything divided by x plus 4 equals 0. Now I have to look at this and say, when is a fraction 0? It's a fraction. When is this fraction 0? Only when the top is 0. Excellent. So now from here I know I will divide both sides by 2. So I know the natural log of x plus 4 has to be 0. Now I think in different terms. I'm asking myself now, natural log of what number is 0? 1. So x plus 4 must be 1. Therefore, x must be negative 3. So since I'm asked about the point, I found x. When x is negative 3 on the graph of this function, I know there is a horizontal tangent, but I'm asked to find the point. How do I find the y-coordinate? I have the x-coordinate, but now how do I find the y-coordinate? Plug it back in the function. So negative 3 plus 4. Natural log 1. 0 squared. So this is the point, negative 3 comma 0, at which this function has a horizontal tangent. It must be a max or a min, and we'll have to talk about it extensively in chapter 4. Okay, I'm looking for another problem. Yes, problem 90. The volume of a right circular cone is, as I mentioned, 1/3 pi r squared h, where r is the radius of the base and h is the height. So here's the cone. So here's the height. And here's the radius of the base, of course. Good. We are asked, find the rate of change of the volume with respect to the height if the radius is a constant. That's part A. R is a constant. So find the rate of change of the volume with respect to the height if the radius is constant. So V, R, and H. Which of these are functions of time? And exactly. So these two are functions of time. So we are asked to find the rate of change of volume, which is dV over dt, keeping this constant. So it's pi r squared over 3. That's constant. So this is a constant, stays outside. And now I differentiate this. What do I get? Yes, the age over dt. This is it. In part B, we are asked to find the rate of change of the volume with respect to the radius if the height is constant. So now pi over 3h is a constant, so I have pi h over 3r squared. So I want to find dv over dt. What do I get? Two pi h over 3 times r times dr over dt. Very good. Perfect. Any questions? I only have 4 minutes left, and I'm thinking to find something short. And definitely, I hope to see you tomorrow at 4:30 if you can make it. I'll be here for you. Yes, 48. Last problem, unless you have questions, of course. Y equals x, hyperbolic tangent, the square root of x. Since I did not give you the formula for the inverse, the problem set has inverse, but I did not ask you to memorize that or remember that. So I just changed the problem a little bit. So we're asked to find y prime. Can anyone dictate? First function prime is 1 times the second function, hyperbolic tangent, plus x times hyperbolic tangent prime, which is hyperbolic secant squared, times the inner function prime. So what is the square root of x prime? 1 over 2, the square root of x. And you don't have to do anything else. So please remember the square root of x prime is 1 over 2, the square root of x. And when I differentiate 1 over x prime, if you remember, it's a result that I kindly ask you to remember. What is this? Because we're going to go backwards in chapter 5. From here. So what is this? Anyone remembers? That's it. So please remember these two. I should have put them on the handout again.